Quite often people have some concerns about our ability to model certain types of projects, and we occasionally are faced with the unknown for the first time. One thing I'd like to include in the future would be the ability to model cloud projects. That's something that we don't have enough experience with right now to be able to present anything to anyone. But that's on our to-do list for the future. But today I'm going to discuss Agile, SOA, and open source because they have come up in the past, they continue to come up, and we want to be able to express to people that we are able to model these things in an intelligent way. Now, one thing I will say is this presentation is not heavy on screen captures from SEER, nor is it a live SEER demo or training session. SEER training we leave to Galarath to do, and for details of how we've set up some of these things, or the details of how some of these things are modeled, obviously we have to scrub that type of information before we present anyone's actual project data out into the public. Usually we simulate that stuff. But for details, anyone is certainly free to contact me afterwards for any specifics, any recommendations on how to deal with the innards of SEER as far as these types of project estimates. So with that said, here's our agenda, very basic. We're going to walk through this in a reasonable amount of time and leave time for Q&A afterwards. As far as background, and this is Booz Allen's background as far as dealing with these types of estimates. Our clients naturally are pretty much representative of everything inside of the federal sector. Booz Allen in the last few years has not had any imprint in the commercial world. That will be changing in the near future. But right now, the focus has been very much federal, Defense Department, civil agencies, Intel, the entire span of anything that the federal government does in terms of software. Our work, that is the group that I work in, is involved in developing estimates, in doing performance assessments on projects, both by those delivered by our company as well as those delivered by other vendors and contractors. And also process improvement, how we apply measurement in order to do a better job of what we would recommend, and in some cases even what we would model would be the effects of improvements in one area or another. Our tools for purposes of this discussion are function point analysis, SEER for software, and on occasion SEER for IT, although this presentation is really geared primarily towards SEER for software. First, we're going to talk about open source. Open source has been around for a while, and it's got a certain amount of popularity to it because it represents essentially free software. Very appealing to those who can find what they need out there. And I will say that there's an amazing array of variety of what is available out there. On occasion, I've been asked to do estimates for what I would consider to be rather confined slices of functionality inside of one or another federal area, and I have been frankly amazed at the amount of open source software that is out there, some of it very specialized, developed initially for some specific user's need, and then gradually adapted to meet other users' needs. But it's amazing what is out there. Obviously, it's in the public domain, and what goes along with that is a license for anyone to use it for free, as well as to modify it or create offshoots, create clones with modifications from it. The support for it, which naturally comes up as a question, when I'm doing cost estimates, I want to be able to make sure that there's no leakage in terms of what costs are represented in the estimate. And so I want to know about, well, who's going to take care of this thing once it's built? It turns out in the open source world, it is considered to be a matter of good neighbors, I guess you would say, or friends of the community. Whoever uses it maintains it. Also, users who spot problems with it hasten to identify those problems and broadcast it throughout the community, and typically pick up and quickly repair what problems they find with it, and announce repairs made to a particular type of open source. So your maintenance sort of goes along with it. Now, I would add that those who use it are those who maintain it. So if you have something that's broadly usable, you're going to find a lot of people willing to use it and willing to support it. If what you create is something extremely specialized and tailored for your specific needs, you're going to find less help available, and it's going to fall more on you as the originator to take care of it. But that's all well and good, and it's a motivation to try to make things generally usable and easily adaptable. And there are many examples of this. I mentioned Linux and Firefox here, but there are more examples than I could even put on several pages of different types of open source software. One concern that we have in the federal sector has been, what about security? And I had the occasion to quiz some people out in California at length about their open source software that they personally were using, what they used it for, and how they managed security on it. And I will say that they were able to answer my concerns very adequately. I will also mention that open source software has been used by such agencies as NASA and has been recommended for use by the Department of Navy. So I think you can draw some conclusions from that. As far as how open source is done, as we mentioned, it's open to the public domain, and there's a license granted to anyone using it. Anyone who wants to can take some open source software and adapt it to their needs, and then put it out there for general consumption. And depending on how applicable they are to other people's needs, they'll be picked up and maintained. Obviously, the question of who's going to maintain it remains a question to be answered first by the originator and then by the other users. And how do we measure it? When I need to do an estimate for something involving open source, I'm looking at this as essentially reuse software. You could consider it COTS, but COTS sort of implies that if you want to modify it, you're going to go through a great deal of tribulation to be able to get the modifications either made by the originating vendor or okayed, and then there's a big dispute about who's going to maintain it afterwards. On this, you're pretty much on your own, so you're basically reusing it. So your typical modeling approaches inside of SEER for reusable software are going to apply. Obviously, user requirements define the needs. Now, the tricky thing about this is usually someone who's looking at open source software is not going to do a very detailed requirements analysis statement first. They might. It can happen. But really the target footprint for open source is something that is needed, is not super sensitive, is probably available out there in some form or other that will generally meet the needs, such as the ability to take care of an inventory system, or to book a hotel or billet rooming nights, things like that, or to set schedules, or to issue notifications. These are some common uses that I have run into in the open source world. Where the user doesn't bother to define the needs, then it's a question of taking what the open source software does and reviewing that with the user to say, well, which parts of this are you actually going to need, and modeling that in terms of what's going to have to be perhaps modified, improved, enhanced, whatever, to fit the specific needs and nuances of that individual user. Also, whatever they need that's not present in there needs to be modeled. So the first thing you have to do is work that through and look at your different candidate open source software original pieces to see what they do and to see how well they meet your needs. Then after that, you've got to model what it's going to take to modify that particular open source origination point to meet those needs. So then you're talking about enhancements, that is, things to be added and things to be modified. Those things, for example, this is a case where function points apply, where you can take those individual modifications, identify the requirements that they're based on, and then model those. So you would break that up inside of your SEER model as things that simply are going to need to be retested and things that are going to have to be built anew or substantially modified. And in some cases, we've gone to the depth of granularly identifying different requirements that are met fully by existing code, met partially, met in some rudimentary fashion, or not none at all. And we'll classify those at different levels of impact so that when we go to modify it, we will model that with a thought towards the relative proportion of effort involved in modifying pieces that fit into each of those categories. So obviously with any cost model, the total cost is a factor that we must keep in mind. We must make sure that all aspects of this are accounted for. Delivery schedule is another one, and quite often this is an appeal of open source software because much of it's already available for us at the start. And as we mentioned, maintenance essentially pushed to the side in terms of open source. We hope someone else likes our version enough that they're going to help us maintain it. If not, we're going to have to eat that cost. So when we're modeling it inside of SEER, we are typically looking at an internet platform, although not always. Our acquisition type is integration with or without change depending on what extent the software fits our immediate needs. And the modifications and new development are modeled and estimated as we usually do inside of SEER for software. Everything has to be integrated and tested. Unless someone's willing to take a great deal of risk with it, and usually our types of clients are not happy with that sort of a risk approach. So we generally say that we're going to make sure that everything is tested at least once to put it into actual use. We may have multiple alternative solutions to look at. So we're going to have to model each one of those individually and do an analysis of alternatives. And let's see. Our comparative costs. We sometimes need to model the effect of actual use, installation, training, etc. For some of those types of things, SEER for IT actually gives us a very convenient way to model that. I've used that on occasion to model things like an ops center, to model based on the functionality being provided how many different people need to be present to perform which different types of functions, and based on the scheduling, whether it's 24/7 or normal business hours or whatever the case may be. Now we're going to move on to Agile. Now Agile has been the hot button, the wave for the last several years. I think right now cloud is eating into a lot of that. But Agile still has a very strong presence in the development world. And the first thing to recognize about Agile, for those that aren't that familiar with it, is it's an approach. You might call it a methodology, although it may be a little bit loose to be called a methodology in some cases. But it's not a specific tool set. It's used with all sorts of different tool sets, and so it isn't simply a matter of saying, oh, well, I'm doing Agile, therefore I'm using this set of tools, and there I know exactly what's going on in this project team. Not the case, unfortunately. The emphasis, obviously, with Agile is on delivering software. It is not emphasizing documentation. In fact, quite often there's very little documentation go along with that. With Agile, there's this intense interchange of information with user representatives to define what the software is actually supposed to produce. That's great, except that it means that there's very little advanced documentation in most cases. In some cases, there isn't much documentation after the fact either. This can be problematic, especially when you're trying to build an estimate early in the development. They also manage to avoid a lot of contract renegotiation, a lot of furthering around with the details of what's going to be delivered and when. Although, again, there's examples of that running awry as well, too, where what's being promised is not delivered on schedule, and this creates some problems with user acceptance. Obviously, the users have to know what's supposed to be delivered so that they can be prepared to accept it. Short delivery cycles. Usually Agile is delivering something within the space of weeks, occasionally a month or two. It depends on the nature of the project, the nature of the team, what they like to do. And also, I'll hasten to add that Agile obviously is not a good fit for all types of projects. There are a lot of highly complex projects that we deal with in our government work that are not realistic candidates for Agile development because of the desire for control, I would say, on the part of the users, and also the need for a great deal of documentation to substantiate what's being built and also what's there to be maintained afterwards. Now, with Agile, they say that requirements changes are welcomed at any point in the life cycle. That is unfortunately true. I say unfortunately from the standpoint, again, of estimation, because whatever we estimate for a given scrum, a given delivery cycle, is liable to be continuously moved around because of these requests for changes. Rigor, as they note, is a relative thing, and what they say is trust dedicated people. Really, with Agile, almost more than anything else, you are dependent on the quality of the people doing the work, because there isn't a whole lot else to hang on to say what's going to be built, what was delivered, what does it do. You're very much dependent on those people and the actual software and whatever documentation they happen to produce along with the software along the way. Now, Agile does appear very informal. To people that are used to the classic waterfall development methodology, Agile is sort of a nightmare. It's sort of like throw all your forms away, never mind the documentation, we're not bothering with change control, etc. That's not really the case. Agile can be extremely disciplined. It just tends to not be, because most often the people that tend to advocate Agile are people that have already run into a great deal of frustration with more traditional documentation-heavy types of development, and so they want to go the other way with it. I don't blame them. It can be excruciating to go through the paper changes, as we experience many times in our work. But it is a trade-off, and it does have an effect on things. So we've got small teams, many short development cycles. A great deal of user participation is supposed to happen. I've run into a few cases in these projects where the user participation is not there as advertised, as planned, and this creates some big problems. Requirements volatility tends to be set very high inside of your SEER model. And requirements management and control tends to be informal, and this leads to a lot of negative surprises. So to model this, you've got to have a fairly decent handle on what they're planning on delivering in a given scrum, and then you've got to be able to tackle them and make them tell you what they're changing versus the original plan, almost on a daily basis in some cases. The skills and experience of the team in Agile development are absolutely critical. That makes all the difference in the world in terms of performance. There is an enormous range of productivity in teams that are experienced at doing Agile development versus teams that are just learning how, perhaps more so than anything else that I've seen. So that is a definite piece of reckoning that has to be engaged. The productivity on an Agile team, if it stays intact and working on the same project, is supposed to improve over time and rather rapidly. I haven't seen enough cases where the actual performance was documented sufficiently to be able to tell that yet. I have one Agile development team that I'm working with on a recurrent basis, and I'm about to go back to visit them in the very near future, 6 months after I last saw them, and see what they've been producing and what sort of productivity changes they see there. And I would welcome observations from other people along the way about what they find there. Team size is supposed to be small. The classical recommendation is 7 plus or minus 2 because that keeps the development cycle short, keeps everyone involved in the team focused. I have seen teams running up to the neighborhood of 20 people, and I would say that there seems to be a lot of effort being expended there without clearly definable productive output in some cases. You can have small teams developing concurrently, but then you have the difficulty and the risk involved with parallel development. And when you have that compounded with an informal development process, or let's say highly adaptive and very fast-moving development process in Agile, multiple teams working concurrently add to the risk as far as making sure that things match up. Reuse of software from other sources, such as Agile sources or other sources, open source software. That software picked up from other places obviously can be applied. How well it fits, I guess, is a question, because Agile projects tend to be for things that are very sensitive to customer needs and nuances and much less related to high security, heavy usage, those types of things. We don't build communication systems in Agile development, I would say, probably as a rule. So how do we measure it? Well, again, each functional requirement is identified and measured for functional size. Now the question is, when do we find the functional requirements? with Agile, they're building and designing this thing. They're defining it as they go. So if you're going to have any requirements to work from, they're going to have to arrive on the fly during the development cycle. Now, we'll talk about backlog in a moment, but a list of requirements to be developed is a potential source of sizing that we can use, provided we're willing to grant a good deal of imagination and assumption into that. They're at a very high level, and because of that, more so than in other development project situations, those requirements are going to have to be inflated to get any sort of reasonable expectation of size. One thing I'll mention later on is that as we get experience from seeing what goes in at the beginning to what comes out at the end, we'll begin to get a better sense of what that inflation factor needs to be, whether it needs to be 20%, 50%, 100%. And that's going to vary also, obviously, based on the nature of the team, the nature of the organization, of the client, et cetera. So there are a lot of buttons to push, a lot of thoughts to be had there as far as how to define an inflation factor for those requirements. Obviously, as they move through the project, this uncertainty diminishes and things become much sharper. However, I find when I go to measure performance, I have to see what they're actually delivering versus what they said they were going to at the outset to see how well that change plays out. And there can be an awful lot of surprises. On a team that I just referred to a moment ago, what they set out to deliver in their first release wound up being substantially different than what they actually delivered because of that. So, each one of these scrums, which in effect is a small release, is modeled separately. And there may be different platforms, different environmental conditions, et cetera, that come to play in there. And then the backlog. The backlog is the ongoing list of things to do, things yet to be built. And the backlog, as we'll notice, doesn't stay fixed in one position. It's going to move along with everything else that's moving. So how do we do this? How do we deal with the estimation for this in SEER? There are Agile knowledge bases, and it's extremely important to choose correctly between whether using novice or experienced team settings, and then to modify those as well to match up what's actually going on. Because, as I mentioned, the productivity is dramatically different between novice and experienced. The team size and experience level and the short delivery cycle govern delivery capacity. And really, the estimation in an Agile environment is really a capacity management game. It's what is the productive capacity of that team, and how much time are they going to be taking to develop and deliver their latest scrum, their latest release increment. And that's how we measure out to see how long it's going to take to build their entire list of things to do contained in their backlog. So for the first cut at an estimate, for their first scrum, their first project, I'll use industry performance experiences as encapsulated in the data inside of SEER for software. Then after that, I'm going to calibrate to local performance. That's extremely critical because regardless of what the industry says, in Agile or anywhere else, your local performance is what you really care about. And while it is like pulling teeth to get them to cough up the hours and to clean up those hours from previous projects so that you have something reliable to model from, to me it is like gold. It is the most important thing that you can pull out of it in terms of their experience. Because how they performed in the past is a pretty good indication of how they're going to perform in the future. And that's what we want to model. Let's see. So then their existing backlog tells a story of what they have on their to-do list. The backlog obviously is not going to stand still. Users are going to add things to it. Rarely they may pull something out of it. And when the team is trying to decide what to engage on, they will typically pick a collection of backlog items that are more or less coherent. They are serving the same type of purpose. They're going to be talking about the same footprint of the overall application because it's just more effective to deal with a collection of things that are in some way related than just a hodgepodge of unrelated pieces. So they'll pick those and they'll work on those for a time. Obviously, as the backlog changes, the overall perception of what it's going to take to deliver the entire application requirement set is going to change. And as I mentioned, we're talking about delivery capacity. That's what we're really delivering in an estimate in an Agile project. Very different from what we're used to in other contained end-to-end requirement statement-driven projects. Okay, now we're talking about SOA, service-oriented architecture. This thing got a very great deal of play a few years ago, and since then it's picked up a lot of negative references, I will say, because while the promise of SOA as building solutions from independent parts is great and powerful, it is extremely difficult to do. It's very difficult to find the parts. It's very difficult to associate the parts and get them to move properly. And we'll notice it's also difficult to not just to estimate, but to test and see what the performance levels are that come out of this collection of parts. So, the ideal way of thinking of SOA is to think of it as a collection of parts where you go into some sort of inventory and say, okay, I've got a shopping list, an application that looks like this. It's got the following set of functionality. Now, where can I find that functionality off the shelf? So I go into my magical inventory and look for parts that match my needs and pick them out, and then ultimately I associate them and instantiate a build or whatever my means is of implementation, and then I have my application, like pieces of Lego blocks, putting them together to create something. That's the concept. And as I mentioned out here, this is more of a pattern or a conceptual approach than a specific architecture. The architecture differs a lot depending on the setting. Who is the user? What type of business requirements are they satisfying? But the idea is to define the interface in terms of protocols and functionality and make this rather like an object-oriented type of approach. So we're looking for reusable components. And we're going to note that the reusable components cost more than non-reusable components. There's a bit more involved with them. Interoperability, loose coupling, so that if in the course of the evolution of the application, we might decide, hey, here's a piece of middleware down here. I've got a better piece now. I'm going to pull that one out and replace it. So what's my impact? What's my risk here? What's my effort and cost involved in doing that? Quite often for those types of things, when you get involved in technical architecture, you need some heavy-duty architectural people involved in helping to produce the estimate, because they're going to have to identify things that are not user functionality, but are system-level functionality that may be played with, must be replaced to match up some architecture where this application is going to reside. I worked on a big migration project a couple of years ago, and one of the effects of that was they moved a lot of functionality which on the surface was not going to change from the user perspective, but the internals of it were going to go through a lot of changes. And so there was a great deal of work to be done to work out the parts inside of the technical architecture that had to be replaced and how to model and estimate the effect of that. Now, with SOA, reuse is the way of achieving greater productivity. So the more opportunities for reuse, the greater the possible payback. It has to be in a situation where there's a great deal of development to be done, typically over a multi-year type of program, where there's a great deal of commonality that can be identified, so that we can then find reusability and gain advantage from that. Or if we need to create something that's going to be reusable, we want to pick those parts out that are going to be maximally reusable and therefore gain from that. I participated in a project a few years ago that involved a great deal of that exploration. And one of the problems that we find with the very large programs, obviously, is that they're subject to all sorts of external effects like budget pressures and vendor relations and things like that. And this makes a long-term strategy rather difficult. Because if you're going to create a plan for reusability based on a certain number of opportunities for reuse, and then later on the funding is cut back, or there's an issue with vendors as far as working together or sharing software, or who's going to produce the ultimate reusable component, and then the other vendors will have to use that one. These are problems beyond technology. These are business problems that have to be solved to make that workable. So it's tricky. It's difficult. It's rather large and complex, more so than the other two that I've already talked about. Again, responsibility for maintenance is an issue. You're reusing parts. Who's maintaining those parts? Inside your organization, you may have someone identified, some group who's responsible for maintaining those reusable parts, or you may be it. You may have to create or extend your organization to support the maintenance of those parts. There's a trade-off, obviously, between the parts. The larger parts have fewer interfaces and do more things, but they may drag in a lot of things you don't really care to have in there with you. Smaller parts, they're more targeted, but you're going to have more work to cobble them together into something that works as an application. Okay. All right. So, I'm with slide 17 right now. The requirements are matched against the components. The components are selected for use from an inventory, we hope. If it's a matter of hunt and peck, this is not the solution for you. Orchestration is what they call the integration of the components, where they're, in effect, making many components work together and all swim in the same direction. The enhancements are frowned on and tightly controlled because of their impact. If something is reusable and it's being modified, the effect of making changes to that may have reverberations beyond what people were originally expecting. So that's there's usually a change control board involved in that. And of course, the trade-offs between using the existing component, modifying one, or developing a new one. There's a great deal of thought process that goes into that, and often many different models have to be created to see what the ripple-through effect is of those. I do find that SEER supports that capability rather well, especially if one sets up to use client mode to model multiple scenarios with many factors in common, so that you can simply change the parts that are being studied as alternatives and make sure that everything else stays stable and is all apples to apples comparative. SOA efforts require a well-defined architecture. Otherwise, you're going to create more trouble than you originally set out to avoid. SOA will compound unresolved data problems. If data formats, if data content are not equivalent in one piece to another, there's going to be an awful lot of modification to make them equivalent. How do we measure it? Again, functional requirements are compared to available component functionality. With an SOA effort, usually there is a good set of functionality already defined, some sort of requirement statements for us to work from. So we use that as our shopping guide to go out looking in the inventory to see what's out there that we can use. We can also, obviously with function point analysis, size those functional requirements in a way that helps us model them. In SOA, data, service, process, complexity, and the enabling technology, these are well represented inside of the SEER parameters. Let's see. The components must each be identified, characterized, and scoped. Each component is, in effect, like a mini application. So each component has its own boundary, its own functional content, its own set of interfaces. This means you're integrating an awful lot of different pieces. So even though you may not be developing much, you will be integrating an awful lot. So the integration testing can be quite huge, and in some cases at least proportionally repeated at multiple levels as these pieces are assembled into ever larger constructs to finally reach the point of being a complete application. So each component has to be defined and understood properly to be able to model it. So you might be modeling the integration of 20 or 30 or hundreds of pieces to be able to make an entire application. Usually there'll be sub-assemblies, and you'll do it that way so that you can contain this complexity to some kind of manageable level. Performance issues are another question. While the entire application might not be held at the same performance level in terms of throughput or reliability, modifiability, etc. Each part of it will have some story to tell, and those aspects have to be modeled. And I will mention that the performance capability modeling of this, which is not something that we're looking at inside of SEER itself, but something that we'd be looking at inside of our own performance modeling capability for a given system, is very complex. Anyone who's experienced the idea of loading something into a system that was expected to perform one way and which instead performed another way, such as it took longer to respond, or there were more users that were going to hit that piece of it than were expected, know that something like that can drive the system to its knees almost instantly, depending on the level of use involved. So that's tricky. That's very hard to do and involves a lot of support from the systems and capacity planning people to be able to modify, rather to model those performance aspects correctly. So inside of SEER, every component will be measured for integration effort. Effort and schedule are modeled for each component independent of other components where needed, that is, in the case of where you're having to build or modify a new component. The modified components are treated as small enhancement projects. The new development ones are development projects. And so your work breakdown structure inside of SEER can be really huge with something like this, depending on the scale of the application. But it's necessary because that's the only way we're going to be able to do this. The modifications or building and certainly the testing of these individual components all create steps along the way in building a schedule. And when you're doing something like this, you have to take care that each individual component, when you look at not just the cost and effort involved, but the schedule, you have to see what the endpoint is estimated for the schedule of those components, and then make sure that the startup effort, or at least the startup of the integration effort of any downline components, is going to come after those. So you will probably have to go into your SEER model and set manually, and in many cases recurrently, the starting date of different downline components to make sure that you don't claim you're going to be integrating with something that isn't yet ready from an earlier build or test. Let's see. The many interactive relationships of these components can make test plans rather complicated and can really hugely impact the testing time. And in some organizations that have high performance or security requirements where there's multiple levels of testing for the entire application, this can extend your time to implementation out by several months in some cases. Not something to be trivially engaged. And let's see. Performance requirements and validation application complexity will be dominant factors in estimating. Okay, that's exactly what I was just talking about, so I've jumped ahead of myself on that one. Future capabilities, things that we would like to see in SEER for software, and I will hasten to add that SEER for software is a tremendous tool. I probably touch it almost every single day in my work. I don't know how often you have occasion to use it, but I'm not going to endorse any particular product or anything, but I will say that it is a very robust product. It has an awful lot of capabilities. And it's constantly being revised and amended and extended and so forth. And we like to offer our thoughts and recommendations along the way. Obviously, one of the first things we'd like to see happen in it is some very strong support for cloud computing, because this is becoming the new dominant mode of software, even more for free, we hope, perhaps, and ultimately at least diminishing risk exposure. So obviously some data has to be acquired from cloud projects, and I suppose that's going on right now somewhere out there. People are doing their cloud projects and are providing the data back to Galbraith to be used, to be built into the next release perhaps of SEER for software. So we're going to need some actual data points on that, and then develop some knowledge bases that go around that. And then from that we could use that to go on and model those projects and compare them to other development modes, other approaches, and see what the costs and the risk and the schedules and so forth are that way. So we would like to see that as soon as Galbraith can manage it. And I'm sure they're working on it now. I'm sure there's lots of people that are suggesting that they'd like to see that. Another one after that is the ability to compare different solution outcomes. Now, SEER does have a great deal of ability to do this right now, especially if you're operating in client mode. For those of you that aren't familiar with that, check into that. That's your way of running multiple parallel scenarios and of being able to keep the inputs all in sync and not have to go back manually, as we had to once upon a time before client mode, and go back and if we wanted to reset, say, a security parameter or a real-time content parameter in a model, and we were maintaining 8 different scenarios for comparison, we had to make sure that we went back and changed that component in every program element, in each work breakdown structure, in each one of our different models. And in some cases, this ran into the dozens and scores of instances where we had to do that. And it's very easy to miss one and then wonder why your results are coming out looking funny in comparison. So that capability does exist. What I'm talking about here is the ability to do it a little bit more easily, more smoothly, and to be able to slam the results side by side in some sort of a representation so we don't have to pick them and chop up and do screen captures and somehow or the manufacturer or re-enter values to be able to represent the outcomes in comparisons of multiple scenarios. And okay, and the last one is a stratified view of processes, projects, programs, organizations, etc. The idea with this is the ability to concisely represent what's going on in a given portfolio of applications or portfolio of projects, as well as multiple projects operating inside of an organization, because there are organizations out there that are not just looking at delivering something, they're also looking at what's my investment look like and where's the best move for me to put my money. So should I press ahead with this project over here? I mean, let me back up just a second. In our work in some areas, truly, and this is probably a good commercial for Agile, the user doesn't at the outset clearly know what they want. So they are playing around with a lot of different possibilities. And inside the federal sphere, as well as in other places you can think of out in the business world, there are many people trying to achieve the same thing through different means in different times and places. They may not know about it, but at least inside of an organization, they should know what's my profile, where am I putting my money, where are all my resources going. This is one of the first things we ask when we come in and look at an organization. What are your resources spending their time on? What's everybody doing? What are they billing to? And does that equate to actual materials being produced? So the ability to look at that and say, okay, here's what's going on over here. Here's the unit cost of production in this environment. Here's the unit cost of production in that environment. Is there any exchangeability between these two? Could we move some of this stuff over there, let them do it, add it into their project mix? So the ability to look at those alternatives and to model that would be hugely valuable there. You know, this could be a very big saver in terms of time, in terms of cost, reduced risk, by eliminating repetitive actions, multiple blind duplication of effort on the same types of things, and then preserve the resources to do things where there's no clear answer to how do you do that. How do you secure the nation's borders? How do you produce the most effective weapon system? How do you most effectively distribute your personnel to do something, to military operations, healthcare operations, civil emergency operations, things like that. So those types of things in a software sense is what we're talking about here. And just to wrap up very quickly, I always like to put this out here. Someone I work with likes to use this very often. A fool with a tool is still a tool. We know that SEER is an extremely powerful tool, and SEER, like other estimation tools, has many buttons that we can press and reset, and it will always produce answers for us. The problem is the answers, do they match up with the reality? So it's not just a matter of pushing the buttons. We need to know how to use the tool properly in the right context. And for that, you need training from SEER, from Galarath, I should say, and you need a good deal of mentoring from people who have been a little bit further down the road than you have in whatever particular area you're working. Calibration. I love to emphasize this. While it's extremely difficult to get the honest-to-goodness truth of what it took to build the last several similar projects, or even just the last similar project, inside an organization that you're working with, that you're trying to do an estimate for the next time. Calibration is gold. You use that, you tune your tool, and then you're getting answers that match the reality there, not somewhere in industry, but right there. Absolutely critical. And the other thing is everything is always going to change, so when you build your models, label them, document them, and make them flexible enough so that you can reuse them, you can adapt them, because I often wind up using a previous a SEER model as a starting point for a new one, and once I'm working on one, inevitably, and I go through this with the clients, expressing to them, you want how many different scenarios modeled do you think at the beginning? Because each one of these is going to be work for me that I have to make sure that everything stays in sync. So I need to make my models adaptable, I'll put it that way. Now, what we don't know yet. How to most effectively model trade-offs. Well, that's going to be an ongoing thing forevermore. We're always going to be trying to achieve better capabilities in that area. And how to show value. Value is a very tricky thing. We can show costs and effort and schedule. If we can agree on defining what a defect is, we can say a lot about that and a lot about quality. But in terms of value, like beauty, is in the eye of the beholder. It's in terms of the context in which something is used. The greatest thing ever built, if not used, is worth nothing, probably, other than perhaps the experience gained from building it. Value is a hard question to manage. It requires a completely different set of measurement capabilities, which are not yet defined satisfactorily, although some people have made some stabs at it. But it's not just a matter of cost. I heard someone once say, well, the value of something is the cost of what it took to build it. That just isn't even close to right. It depends on how it's used, if it's used, where, when, who, etc. And where we're going to go from here? Well, we're always experimenting and devising extensions to existing tools and trying to adapt tools. Every time I do a function point measurement on something, I modify not the rules that I measure the function points by, but I modify what the other data besides the requirements and the size are that I'm collecting along the way, because that bears a lot on things like when I go to build my SEER model, what language, what environment, what tool set, experience level, type of application, platform, etc. All of those things matter, and some of those things have to be segregated and modeled in clusters so that they can be reflective of reality. We're always talking with Galarath, and they are very responsive to us as far as improvements to the tool set. And our clients, we like to educate them on what we can do, what we can't do, and identify what their needs are, and try to step it up a notch. And with that, I am done talking, and I will be happy to answer any questions